Hello and welcome to The Conversation. My name is Jade and I will be your host for today's show. I also have with me Lisa and Athena and of course the epic Dutta producing the show. So today in news we have
bacterial nanowires
and space eyeballs.
Plus, we have an interview with Guy Trudell about the MARROW experiment and your questions and comments from last month's show. All that and more coming up on tomorrow, Science Experiment 1.04. Before we start, we'd like to give a shout out to our citizens of tomorrow. These are our Escape Velocity citizens. They contribute $10 an episode on Patreon or $30 a month on makersupport.com. Some of the goodies they receive is the name in the show during all 3 segments, access to our exclusive citizens-only hangouts, and of course, early access to After Dark as soon as it's available on demand. If you would like to contribute to the shows of tomorrow, head over to Patreon/tomorrow or makersupport/tomorrowTMRO. So the first story we have today is actually a little creepy, I'm not gonna lie. It did kind of disturb me a little, but I'll go ahead and let you explain it. So Athena, space eyeballs?
Yes, space eyeballs, and I am not referring to when you take your helmet off in space and your eyes are like totally blowing out of your face looking like a cartoon. I love Who Framed Roger Rabbit. No, I'm like actually referring to being in microgravity and being in a pressurized, oxygen-flowing space station like astronauts on the International Space Station. Most importantly, what I want to convey is just why this is important that we're doing research on the eyeball in space. Our eyes affect our every way of living. They play a vital role in our everyday lives, especially for astronauts in space getting work done like experiments or spacewalks. Like really, you do have to know where you're going. And at the University of Houston, an optometrist relayed this importance in his research. His name is Nimesh Patel, and he's conducted studies in the changes found in the eyeballs of astronauts that have been in space for a long duration of time. This study was done by using optical coherence tomography imaging to determine just how fast these ocular changes develop during spaceflight and how long it takes for patients to recover. Now, optical coherence tomography is a non-invasive clinical test that offers cross-section pictures of the retina. By studying pre-flight and post-flight data from 15 astronauts who had spent time aboard the International Space Station, scientists found changes in morphology of the eyes, meaning they found a lot of changes in the shapes of the eyes. Spaceflight-associated neuroocular syndrome, also known as SANS, is a phenomenon where the structure of the eyeballs of astronauts change, which can affect their vision. Even though it's been recorded that a lot of the subjects actually had really good vision before and after the flight, despite having these morphological changes in the structure of their eyes. His algorithms showed that following prolonged spaceflight, 3 major changes occur. The first one is there's a change in the position of the Bruch membrane opening. The second one, an increase in retinal thickness closer to the optic nerve head rim margin, and an increase in the proportion of eyes with choroidal folds. So for individuals exposed to a long duration of microgravity, their eyeballs are going through some interesting shape shifting. As of now, the exact cause is unknown, but it's hypothesized that these changes seen in astronauts are a result of cranial fluid shifts associated with being in microgravity, aka the movement of fluid in the cranium or skull from being in microgravity. Now keep in mind that some of the astronauts in the study had previous spaceflight experience, so the pre-flight data was first compared with healthy control subjects before making the comparisons to the post-flight data. This is a quote from Patel. He says, "The results of these investigations suggest that although there may be resolution of structural changes, there could be long-term ocular anatomical changes after extended duration spaceflight." Now, the overall hopes of this experiment are that one day this research will lead to the development of applications for patient care. He reported his findings in the JAMA Ophthalmology. I want to end on this note. moving forward in human exploration to the cosmos, we have to be sure that our vision and physical well-being is protected and at its best and healthiest. And in my time hosting on the Tomorrow Show, I've gathered just how passionate the Tomorrow community is about space travel and truly seeing humanity expanding their reach to the cosmos. So, I mean, even just that image, that last one that I left you guys off on, I love that so much about you guys. That we really have this passion to see humanity landing on Mars, having just interstellar travel and actually being on planets. So this research is super exciting, and it's really vital to understand like the effects of being in microgravity.
Yeah, no, absolutely. And I'm glad you brought that up too, because when it comes to some of the biggest challenges facing long-term space flight, especially to Mars and beyond, a lot of it is, we study the muscular atrophy, which is in a previous episode if you want to check it out. And we've also studied like other things, and it's like, what are we doing to take care of our men and women that we're sending out there? I mean, they're doing something amazing for humanity, but when they come back, I mean, are we really putting their health at risk? Are we really degenerating some of their senses so badly to the point where it could, down the line have some really bad effects? So. Pretty important stuff.
Yeah.
Wow.
The cool thing about studying things like this fluid shift that kind of changes the eye in space is that it's also applicable to people down here that suffer from things like intracranial hypertension. So the study that we do on the space station, it helps people down here as well that have kind of like similar ailments as well.
Exactly.
Yeah, definitely.
Bringing it back down to Earth.
Always.
Nice. And speaking of Earth, I see here you're going to talk to us about some bacteria that can generate electricity.
Yeah, really, really cool stuff. Bacterial nanowires. So there was a study between Caltech and the University of Southern California, and they released a paper this month in March 2018 in the journal PNAS, or the Proceedings of the National Academy of Sciences. And they actually found a way to visualize bacterial nanowires. So cool. So this is some footage here of a bacteria called Shigella 1diensis, which grows tendrils or fingers of its cell membrane when it's stressed or lacking oxygen. But it also has the ability to pass these electrons from its body to outside external surfaces. And scientists haven't really been sure how the Shigella bacteria did this until now. So what they did is they grew the bacteria, and you can see lovely tendrils coming out there. It's really, really cool. They grew the bacteria inside a chamber that was attached to a light microscope, and they're actually able to image the bacteria growing. And they knew from previous research that these membrane fingers contained lots of something called cytochromes, which are proteins that contain the compound heme. Now, you might be familiar with the compound heme because it's part of something called hemoglobin, which we actually have in our blood. And heme itself, the molecule, is really good at carrying around electrons. But the researchers weren't actually sure how these cytochrome proteins, the ones that have heme and protein mixed together, they weren't sure how dense they were along the length of that finger-like projection. And so they used a new technique called electron cryotomography, where the cells were snap frozen and imaged in 3D at much higher and clearer resolutions than is possible with just using light microscopy. And they found that the cytochromes were arranged along the length of the membrane finger, in some parts actually touching, and in some parts as much as 30 nanometers apart. And this next image is a visual representation of what this might actually look like. So the next steps are to measure if these cytochrome proteins, which are like the green and red blobs you can see in this image, the next steps are to measure if they are floating along the membrane, or the yellow part there itself, and transporting electrons from one end to the other. Because, I mean, ultimately, by understanding this, we could harness microbial electrical power. Because microbes like this, Shigella, actually can digest waste products and then make electricity from that. So, like, maybe we can make a microbial fuel cell where we take those bacteria, we make them project these finger things onto waste, and then, like, they become wires, and we, like, harness it like a fuel cell. But these types of organisms are also really good at surviving in environments like the deep ocean, or maybe even under the Martian surface. So these are really, really cool bacteria.
Kind of like extremophile.
Yeah, like the coolest type of extremophiles, electric extremophiles.
Well, that's so exciting though, because I mean, anytime we look at a way, or that we discover a way that we can harness energy from, or electricity from something that's organic or from something that's more green, I mean, that's always going in the right direction, especially with, our problem with fossil fuels these days.
Yep.
Any little advancement or any big advancement's pretty important. So Awesome.
Really cool.
Nice. So speaking of electricity, actually, I believe you need to tell us about a new form of electric matter.
Yes, yes. I actually I'm really happy, Lisa, you ended up doing that one because I really wanted to do that topic. But this one is amazing. And it's called quadrupole topological insulators, aka QTIs. I love acronyms, makes things a lot easier. So it's amazing experimental findings for something that was predicted through theoretical physics. So this is like really, really exciting that they were able to do this. Now, QTIs are considered to be a new phase of matter. As many of us know, the phases of matter are solid, liquid, gas, and plasma, of course. But with electrons, with different materials, they can also form unusual phases like a TI. Now, TIs are a material composed of electrical insulators on the inside and conductors around the outside. Scientists have found that there are uncommon properties in TIs which make them out to be a special form of electric matter. These materials and new forms of electric matter are important because they may hold great potential for helping build low power yet very powerful computers and devices, and all defined on the atomic scale as opposed to the quantum scale. TIs gave birth to now QTIs. Now, mechanical science and engineering professor and senior investigator Gaurav Bal is working on developing these QTIs in a lab. The team actually built a workable scale model of a QTI using a material created from printed circuit boards. Each circuit board holds a square of 4 identical resonators, which are devices that absorb electromagnetic radiation at a specific frequency. The boards are arranged in a grid-like pattern to create a full crystal analog. Now, the reason for these boards being in a crystal-like structure is because TIs typically exist in a crystalline materials. And there have been plenty of studies that confirm TI phases to be present in naturally occurring crystals. There's one prediction, however, that scientists are hoping to confirm in the future that with studies that there is an existence of a new type of TI which has an electrical property known as a quadrupole moment. Quadrupole meaning that electrons in crystals can collectively arrange in a way which will give a charge in dipole units. Dipole is the pairing of positive and negative charges. Quadrupole is a high order of multiples with 4 or 8 charges, and they're all brought together in one unit. And here we have the simplest member of the higher order classes, which are quadrupoles, where there's 2 positive and 2 negative charges, and those are then coupled together. Now, this might make sense, but how in the world do they even get electrical charges generated in these QTIs in the first place? Microwave radiation. They applied microwave radiation to the system and measured how much is absorbed by each resonator. Yeah, I included that silly little photo of an actual microwave. How much is absorbed is what shows how these electrons will behave in a crystal-like structure. The more microwave radiation is absorbed by a resonator, the more likely it is to find an electron on the corresponding atom. Now, each resonator behaves like an atom, and the connections between them behave as bonds would between atoms. Now, what's funky, as you see here, is that only the corners of a QTI are conductive, and they begin vibrating and generating an electric charge when zapped with the microwave radiation, yet the edges remain inactive. The 4 localized point charges are what forms the quadrupole moment that I had mentioned earlier. Now, future research actually includes continuing partnership with engineers to further develop these new forms of electric matter. So all these images are just computer simulations, but they are actually creating what was theoretical and all computer models, and they've made a physical atomic scale of it, like an actual physical form, which is really exciting in a lab. And so they're looking to actually create more of this so that we could really create like much more powerful computers and with a lot more data. So
oh my gosh, that's so exciting.
That's
like
awesome.
I love it when we hear these stories about something that, as you said, existed only in the realm of theoretical physics.
Yeah.
Which, let's be honest, like there's so many amazing, beautiful, fascinating ideas in that realm, but then to actually see it kind of materialize almost is like, whoa, it's almost like sci-fi becoming reality. Although it's not sci-fi initially, we know it's actual science, but still, like that's really awesome. And as you said, that exponential leaps in computing. So
yeah,
keep my
definitely.
eye out.
Because I know right now we use quantum computers, so it's kind of use this would just be like double the amount.
No more lag on Xbox Live. Whew.
Yeah.
All right. So our next story. So Lisa, you're going to tell us about some chameleon materials, and I'm not going to lie. I looked at this, and the first thing I thought of was Mystique from X-Men, and how she can change her skin and kind of just Is that what
I mean,
you're
it's
talking
kind of
about?
like that. It's all about making materials that have really, really cool properties. So researchers
okay.
at the University of North Carolina and Lomonosov Moscow State University have created a new type of chameleon skin material that behaves kind of just like real skin. And they published this in the journal Science, which is a really high prestigious journal. And they published it yesterday, so it just made the timing for this show, which is amazing, really cool science. But why is this material special? Well, it changes color according to the amount of mechanical strain placed on it. And to create it, scientists poured a polymer over closely packed building blocks to create what's known as a copolymer. Now, this visually stunning property of this copolymer was actually an unintentional side effect. The researchers were trying to create a material that was soft and yet stiffened when stretched. And that's because many biological tissues throughout our body have this ability to harden upon being deformed. So a synthetic material with this property would lead to better medical implants and prosthesis. And the copolymer was even compared to pig skin, and that's in the bottom left-hand graph you can see on the screen here, porcine meaning pig, and the different labels are for the different samples of the new fancy material. And it reacted the same way mechanically to mechanical strain. It's believed that these properties are due to the structure of the copolymer building blocks, one of which the scientists are calling a bottle brush shape, which you can see in the top left and top right-hand images. It's kind of like flat, and then it has these bottle brush fingertips coming out of it, and they actually self-assemble themselves into a more complex structure, which you can see in the top right-hand there. And it's thought that these bottle brush molecules become hard when they get pushed because all those bits of the brushes actually tangle up together, and that's why it kind of resists when it gets a force applied to it. And this is an image here of a piece of that wonderful, beautiful material. And the edges are actually a different color because of the way that the light is physically passing through that material and the way that it diffracts. And ultimately, this is a great example of how sometimes in science, you can find unexpected answers when you're looking at new things, and I'm really excited for more research to characterize this material even further because I think it could have some really cool applications. Maybe not so quite mystique, making our skin, you know, like turn different colors and stuff, but it could lead to really cool implants that react the same way that your tissues would. So otherwise, you know, you could get inflammation if like you have this really hard piece of implant inside you and your body is soft and moving around it.
Exactly.
We need to kind of mimic the human body a bit more to make these things better suited for us. So this could help.
And that's so amazing too, because like kind of the like it's like design meets engineering meets science, and then what we get is this like amazing product out of that that could ultimately help like thousands, if not millions, of people down the road.
Definitely.
Because as you said, like when it comes to grafts or things we have to put inside of us that are foreign, I mean, our bodies aren't always super cool with that, and so that's how we get, like you said, inflammation and things that are just not that fun. So hopefully this cool Mystique skin makes its way into some really cool applications, if not a cool Halloween costume.
Definitely.
All right then, so we are going to go ahead and head into a quick commercial break, and when we return, we are going to have a fascinating interview with Guy Trudel.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end.
T-minus 1 minute.
We've only just begun.
Orion organ is functioning perfectly at this point.
Come with us and explore tomorrow.
And welcome back to Tomorrow. Now, before we get into our interview segment in today's show, I would love to give a huge thank you to the crowdfunding supporters of the show, specifically our Escape Velocity citizens. These are the people that contribute $10 per episode on Patreon or $30 per month on makersupport.com. But we also have our Orbital citizens. These are the people that give us $5 per episode on Patreon or $15 per month on makersupport.com. They get their name in the show during the second and third segment and access to our exclusive citizen-only hangouts, as well as much, much more. If you would also like to help contribute to the shows of tomorrow, head on over to patreon.com or makersupport.com/TMRO. Now, I would love to give a huge thank you also to our very first interview for Tomorrow Science. We have Gay Trudell, a doctor from the University of Ottawa who is the principal investigator of the MARROW scientific study. So thank you very much for taking time out of your day to join us.
My pleasure to be there, participate in your program.
So for those that don't know, the MARROW study stands for, I think it's a backronym, Bone Marrow Adipose Reaction Red or White, which is a fantastic investigation name, by the way. It's a great use of bacronyming, and I think it's really cool. But the first question I wanted to ask today is, why do we actually need to study bone marrow in space? Like, what's happening to astronauts up there? Are there negative changes occurring?
In fact, we don't know yet, Lisa. This is what MARROW is for. We want to know what's happening. We know that there are lots of changes in the bones when you're in space, but thus far we haven't studied the bone marrow. And I'll tell you why it's important. The bone, of course, is the organ that provides structure to your body. But inside the bone is a complete organ, and this organ is actually a site of production of all of your blood cells, your red blood cells, white blood cells, and platelets. Without them, you can't survive.
And so what kind of data is MARROW trying to collect? So what are the different parameters that you'll be looking at with this study?
Yeah. In the bone and joint lab, which I direct, we were very interested in the musculoskeletal effects of immobility. And we realized, in fact, we were not even looking at the bone marrow initially. This was a side discovery, distraction. We were looking at changes in the joints when the limb is immobilized. So changes in the cartilage, changes in the joint capsule. But we were constantly distracted by what was happening nearby in the bone marrow of the animal research we were doing on joint immobilization. And the big changes was a significant accumulation of fat. So the bone marrow was very different from a normal animal, for example. It was, instead of having lots of blood-producing cells, it had lots of fat cells. And that kept intriguing us until we decided to go ahead and study that.
So in a healthy bone marrow, what's the kind of ratio between like normal cells and fat cells? What does a healthy person's bone marrow actually look like inside?
That's a key question, Lisa. In fact, when you're born and when you're very early in age, an infant, most of your bone marrow is red. That is, it produces red blood cells. And as we age, all of us, there's a transformation called bone marrow conversion. And less of the bone marrow space is devoted to blood cell production, and more is actually filled with fat. And that's a normal process occurring in all of us. However, there are factors that can accelerate that conversion, and we know of a few. And researching immobility, we discovered that immobility was a very potent factor to change the bone marrow, to accelerate the conversion of bone marrow from blood producing to being fat. In fact, when we're adults, most of our bones stop producing red blood cells and white blood cells. So all of the limb bones have stopped producing, and the bone marrow production is limited to the vertebrae, the pelvis, sternums, more the central bones.
So this change between getting more and more fat accumulation in the bone marrow, I guess that's what you guys are kind of investigating at the moment with this study. So how do you actually measure the amount of fat that's in the bone marrow in this study? Is there a specific kind of tests that you're doing to look for that?
Historically, when this was measured in people who were in bed or people who had paralysis, that's how we discovered that immobility was leading to fat accumulation. This was all done by biopsies. So we were taking a trephine, metal trephine, and we were taking biopsies of the pelvis. But these days, with magnetic resonance imaging, there are specific sequences that are designed that you can non-invasively put a person in a magnetic resonance imaging, an MRI machine, and measure precisely the fat fraction, the quantity of fat, and then measure changes over time.
I'm really glad that there's a better way to do that, because taking a biopsy of a pelvis sounds incredibly painful. So I'm glad that we're using MRI machines to kind of look at that and study that as well. So we're looking at the fat that's accumulating in the bone marrow, but are there any other parameters that are interesting to look at as well with this study?
Yeah, that's the other part of MARROW, the red or white. So red or white doesn't refer to red wine or white wine. It refers to red blood cells and white blood cells. So the question we asked, our hypothesis is that if this fat is accumulating at a higher rate in space when there's absolutely no force acting on the bone, save for the exercises that the astronauts do, would that affect the red and white blood cells? And there is already data, and there are conditions, for example, a condition is called space anemia, that is well known, and also some more vulnerability to infections that is dependent on white blood cells. So we wondered what effect would these changes in the birthplace of these cells would have on these diseases. So we will measure changes as well in the red blood cells and the white blood cells. And for the red blood cells, the main theory at this point to explain that the red blood cells are decreased when you go in space is that they are destroyed. So very early when you get to space, you will destroy 10 or 15% of your red blood cell. This is what we measured so far with markers, with radioactive markers of red blood cells heading into space and then coming back and then measuring that. But what we wanted to do is find a way to directly measure the red blood cell destruction called the hemolysis. So we designed a way where we could precisely measure hemolysis in astronauts in space. And that is done in a very interesting way. It's done actually by measuring a component in the breath of astronauts, in the expired air.
I believe we actually have a video of the experimental protocol and the kind of equipment that the astronauts would have to use for that. Let's take a look.
You are about to set up the hardware in preparation for a breath sample collection and an ambient air sample collection. The purpose of this protocol is to compare the carbon monoxide level in your lungs versus the one found in the ambient air. Sampling must be done as soon as you wake up in the morning, even before opening the crew quarters door. During this setup activity, you will pre-assemble some hardware. You will need a breath sample collection kit, 3 canisters, a QD valve, and a fine point Sharpie. First, retrieve the T-piece and verify that the flutter valve, that's the item with the membrane, is still in position at the bottom of the T-piece. Insert the discard bag at one end of the T-piece and the mouthpiece at the opposite end. Pay attention to the orientation of the mouthpiece. Place it horizontally like this. Insert the bottom of the T-piece in the inflow valve of the sample bag. Make sure you orient the mouthpiece in that direction. Insert the QD valve firmly into the outflow valve of the sample bag. You're now done with the pre-assembly of the items. You can put the assembly back into the Teflon bag until it's time to use it.
I feel like the cool thing about this is that all that equipment there is like, there's nothing super duper fancy. Like, it's a vacuum canister that's going to pull in the breath sample, and then all the astronaut needs to do is kind of blow into this bag. Like, it's an incredibly simple way to measure something really cool. How long has that been in development for?
Well, we were carrying those experiments on the ground, and initially when we wanted to do it in space, we said, well, instead of this complex procedure, we'll just ask the astronaut to measure their concentration of carbon monoxide in space. But the amount of equipment needed and the expertise and the time needed just made it impossible to plan. So if you can't bring the machine to the astronauts, we said we're going to bring the air down, we'll down mass it and measure it in our lab. So that's how we come up with this simple, but yeah, there are a few instructions that the astronauts have to follow in a very specific way. And there's some technology, even though it's low technology in terms of the flow of air, in terms of eliminating some part of the air called the dead space and keeping only the alveolar air, and then transferring that into this inert canister that would have a long shelf life, because it would be stored for a while, waiting for the next Dragon flight down to the Pacific Ocean and then to our lab. So this could be a number of months. So there were a number of criteria that had to be met for the sample to be in good quality for measurements when it gets to our lab.
There's so many things that go into
But that's cool stuff.
Yeah, there's so many different factors that you don't think of, like the dead space of the breath. That's the first part that comes out, right? So you have to have a way of making sure that you don't collect that, but you want to collect, where your sample is actually going to be the most useful. So it's really cool.
Exactly.
Ingenuity.
Go ahead.
Yeah. So I have a few questions from the chat room that I'd like to bring up as well. So talking about the accumulation of fat building up in the bone marrow, Prismara from our chat room says, how can we reverse that? Because that sounds really bad. Is there any way to kind of build up that accumulation of fat that we think is going on?
It's a very good question. There is not a lot of research on that. And unfortunately, the answer will be quite concerning. Before going to run this experiment in space, we ran the experiments in space analogs. And those are bed rest studies. So people, if you're familiar, people are in bed, head down 6 degrees for 1 month, 2 months duration. And we measured the changes in the bone marrow, fat fraction, as we call it. We found that it was accelerated, and not a little accelerated, markedly accelerated. For example, in a group of 24 women in bed for 60 days, their bone marrow aged 4 years in those 60 days. And we were able to measure them a year later, and there was no reversal whatsoever. So that's a bit concerning. We're not too sure how reversible the fat is once it's grown into your bone. We just recently, in January, published a study where we looked at that in humans, practicing different sports. And we found out that people who were runners were able to keep their bone marrow fat fairly low, but people who did not have repeated impact on their spine, because we're measuring that in the vertebrae of the spine, such as cyclists or people who are sedentary, did have no protection of their bone marrow. That is, they had significant marrow accumulation. So we will measure, as part of MARROW, we actually will measure the reversibility. We will ask the astronauts to come back a year after their flight, and we will see if it has reversed or not.
That's incredible, the fact that it's not reversible unless you have that kind of force, applying to the vertebrae of the spine. It leads directly, you already answered the next question I was going to ask from Hannes Worswerp from Twitch that asked, does exercise reduce the accumulation of fat in the bone marrow? Or could there even be some kind of clothing that could provide mechanical stimulation, or maybe a type of medication? But I guess, again, it has to have that force hitting the vertebrae to kind of change that. But what about any medications?
Those are very good. Those are 3 very good questions, in fact. Medication is being used now for the reverse. There was a paper recently published where people with leukemia who have accumulation of abnormal cancer cells in their bone marrow, people have grown fat, and fat has negative effect on the white blood cells. So the fat actually, they were given a medication called rosiglitazone, the PPAR gamma agonist, to grow more fat in the bone marrow, and that helped curing the leukemia. So there's actually a way to intervene with that. The clothing is interesting because in another study we carried out in Berlin, the patients who were in bed rest, the volunteers, actually underwent whole body vibration. So they were exercising, resisted exercises, and were receiving whole body vibration. And those were able to prevent some of the fat accumulation that the people who were in the control group had. So there's a hope that we can find a type of mechanical stimulation that could prevent the increase. That doesn't mean reversibility, we saw that we were able to prevent the increase, but we have never measured so far reversibility of fat already accumulated.
I have another question that sort of leads into that. Not so much about the fat, but about the hemolysis or reduction in red blood cells that's happening as well. Neuropilot on Twitch asked, there is medication that can cause hyperproduction of red blood cells, which notoriously has been used kind of illegally for some athletes. But would that help astronauts or space travelers or people immobilized down on Earth?
Yeah, good question also. So erythropoietin is able to stimulate the bone marrow. We do not have evidence that the bone marrow is not fully stimulated in space. Initially, the hemolysis is thought to be there in order to account for too many red blood cells when there's the fluid shift that you talked about in the first part of your program. So the fluid shifts cause a concentration. There's too many red blood cells and you need to get rid of them, or the body decides to get rid of them quickly. But what happens after that, after the initial 10-15 days, is much less clear. And I think MARROW will provide the very first data on that. Are we continuing to remove red blood cells? Is there a problem with production? Or both? That is unknown yet, and we hope to be able to provide good data on what's happening after the initial adaptation to space.
That's such a cool amount of data that you're collecting, that it's just different parts coming together, like you're doing the MRI stuff, but then also looking at the red blood cells and the white blood cells as well. So are the astronauts actually going to have to draw blood in space for that?
Yeah, they do. In fact, the astronauts, among the many things that they have to practice and be able to operate, they have to be able to draw their own blood alone or with a partner. So there are very good YouTube videos. I think Tim Peake, whom you see on the picture, has a video of self-blood collection in space. It's amazing how agile he is. And oftentimes they have to collect a number of blood tubes. This is Randy Bresnik also doing a collection for MARROW. And in front of him, maybe you don't see it on the picture, the bloodletting is one thing. He has to fill a number of tubes, specific tubes. But then there's a whole procedure. There's no nurse in the clinic or lab people. So they have actually to let the blood stand for some time, then centrifuge them at specific conditions, and then they have to take them and freeze them in the minus 80 freezer on board the space station until it could be brought back. This is again Thomas Pesquet, the French astronaut, who's storing some marrow samples after the procedure. And this is the way the tubes will actually be loaded on the Dragon and come back to space, and come back from space to our lab, maintaining the cold chain.
How important is it to be able to have that down mass capability? Because you mentioned that your samples are coming back on Dragon, and right now at the ISS we only have the ability to down mass with the Soyuz and Dragon. So has that kind of enabled you to do research and collect samples that, 10 years ago you wouldn't be able to do? Like, how has that kind of changed the science that's available?
It is absolutely essential. And even the next step, as you know, is to possibly bring machines on board that will be able to do simple measures or even sequencing for bacteria or others. The down mass is a big advance, and we're happy we're able to do that. Our study could not proceed if it hadn't been for this capability.
That's so cool. I have one more question about the breath collection aspect of the study. Astro YYZ in our chat room asks, why does the breath sample have to be collected first thing in the morning? Is there a reason for that timing?
Very good question again. The reason is we want to measure the concentration of carbon monoxide, the elimination of carbon monoxide, but that will be fluctuating. There's a circadian rhythm to that, and also that can fluctuate depending on your ventilation, your alveolar ventilation. So we want to take the same period of time, the same time of the day, and also stabilize ventilation. So the first thing in the morning is the best compromise we found. For example, we know that the astronaut hasn't been exercising before and accelerating their ventilation rate. So both for circadian reasons and for stabilizing the alveolar ventilation, because on that number, on the breath sample that we collect, we will assume that there's a steady collection throughout, a steady ventilation throughout the day.
Wonderful. So the MARROW study it wouldn't be possible without a bunch of different collaborations and a really big team, because I assume it's not just yourself that's part of this study, but it reaches between the University of Ottawa and the Canadian Space Agency. Can you tell me a little bit about the kind of size of that team and who are the different collaborators that are working on this study?
We've had many collaborators, at least 4 scientists at the Canadian Space Agency who is funding the study are permanent part of the MARROW team. Then the MARROW itself is a very multidisciplinary team. We have biologists, microbiologists, pharmacologists, statisticians, engineers, to be able to operate. And in order to prepare these studies for space, we also counted on a number of external people. For example, the Johnson Space Center Toxicology Lab was using these canisters to monitor the air quality aboard the space station. So rather than inventing a new way of collecting air, they helped us prepare this. Also, the greenhouse laboratory of Environment Canada in Toronto, Canada, also helped us measure precisely carbon monoxide concentration in small amounts of air, because we get about 180 cc's of air. This is relatively small to make the precise measurements. So lots of people involved in that, and very dynamic as well.
I love that there's all different cross-disciplinary collaborations going on, cross-national collaborations. It kind of goes to show how cool that science, the best kind of science comes when everybody collaborates, and I think the ISS is a laboratory that kind of facilitates that, which is kind of awesome. So just before we wrap up, I just wanted to ask you where people can find out more information about yourself and about the MARROW study.
At the Canadian Space Agency website, there's a story about MARROW, the promotion of MARROW, and we're available at the University of Ottawa if you want to contact us through our email or through the website of the university, and that'd be a pleasure for us to consider all the good suggestions that your audience has and entertain questions as well.
Wow, that's awesome. Thank you so much for taking time out of your Saturday to talk to us today. And also, good luck with the CRS-14 launch, because you're sending up some equipment on that. And fingers crossed it all goes well for you so we can get some excellent data back down on the ground as well. So thank you very much.
Thank you so much for having me.
All right, we are going to take a quick break, and when we come back, we're going to have questions and comments from last month's show. Stay tuned, we'll be right back.
Science. It both draws us together and tears us apart. Brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Hello and welcome back to Tomorrow Science. We're going to go ahead and dive into your guys' comments from last month's show, but before we do that, we want to give a shout out to the citizens of tomorrow. These include the Escape Velocity citizens, those who contribute $10 an episode on Patreon or $30 a month on makersupport.com. Our orbital citizens, which contribute $5 an episode on Patreon or $15 a month on makersupport.com. And finally, our suborbital citizens, those who contribute $2.50 an episode on Patreon or $5 a month on makersupport.com. The benefits of being a citizen include getting your name in the show during the third segment, access to our exclusive citizen-only hangouts, and early access to a view-only copy of the show rundown. If you are interested in contributing to the shows of tomorrow, please head over to patreon.com/TMRO or makersupport.com/TMRO. So last month's show got pretty interesting. We discussed the ethics of using animals in lab testing, and it got pretty interesting. Certainly the chat was on fire with all sorts of interesting insights. So before we dive into the comments pertaining to that, the first comment we're actually going to address is that from Smokescale Aquatos, great name. and they said, I want science assemble to be how you start or end the cold open for TMRO science from now on. Ladies.
Thank you, SciComm. I'm going to call you SciComm from now on because in the space show we have Capcom, so I'm just sciencing it up and calling it SciComm. So you are our SciComm for today. Thank you.
Yes.
But yeah, Science Assemble.
I love it.
I didn't know what that was from until I watched Anchorman, which was all of like last week.
And it was life-changing, wasn't it?
It was life-changing. That movie
Good.
is amazing.
I'm glad you think so.
And we need to use this in the show now. That's happening.
Well, thank goodness.
Yes, I'm definitely down for that.
you're down for it, right?
Yeah,
You're down
we
for
put
it.
together like a choreography.
Ron Burgundy can do no wrong. And then we'll end it with jumping, and then it'll freeze right there, awkwardly.
Let's
Can
do it.
make a GIF out of it. I don't know.
Yes.
Yeah. Okay, good. I'm glad we agreed on that. Nice.
That was too
Thank
easy.
you. Thanks, Smoke Scale Aquatos. This next comment comes from ADD Dude, and they had a note that said, my only problem with the show so far is that the main segments are just people having a chat about something they only have vague knowledge of. For example, if you talk about animal testing, please get someone in who does that for a living or works on an ethics committee. I want to know what goes into making the decision to conduct these tests. I also want to learn about examples of how it's done. The premise of the show is to educate and to inspire. News segment does that. Main segment, not yet.
We're getting there, and that's why we love getting your feedback. So if you have any more feedback for this show, how we can make it better, because we are always trying to make it better, please leave your comments below. We want to know, and that's what we're doing. We're trying to change it up. We're adding guests.
Yeah.
In fact, the
Lots of
next 3
guests.
shows have guests. So
See, we heard you.
yeah, we're listening. We're listening, and we're making changes to always make this better. The show is about educating people and inspiring people about science.
Yeah, and starting a conversation as well.
Exactly.
Yep, exactly. And I like having a lot of guests on is definitely something we've been doing, and I think it's going to be really, really good. So thank you so much for that comment, guys.
Yeah, we appreciate it.
Constructive. I like
Yes.
that. Yeah. All right. This next comment is from YouTube. Jax Vidstar writes, most of the animal testing will be ending anyways with the slow introduction of 3D printed livers, which will speed up drug testing as well. Yes.
Sounds really cool.
I think that is the ideal place that we will be. But I remember one thing we brought up during that, the problems with 3D printing organs is that they still don't act biologically similar to what an actual organ in your body does. But yeah, no, I mean, like with the advancement of the different materials, like you actually had mentioned in the news, I mean, goodness knows what we're going to be capable of in 5, 10, 15 years' time.
I guess the flip side of this too is like, the key point here is slow introduction of 3D printed livers. Like, we're not there yet. Like, we don't have that tech right here, right now. So, you know, we still need to do medical science today. We still need to do experiments. So we have to work with what we have at the moment, which is not 3D printed livers like that actually work like a human liver does. So
Much more testing done.
it's a process.
Maybe
Yeah,
someday.
yeah,
It's
definitely.
the dream.
Yeah.
We could get there. I mean,
I see it moving in that direction.
exactly. I mean, just a
Yeah.
few decades ago, some of the things that we're doing with like human bodies right now and with like medical advancements that weren't even thought possible like a few decades ago. So,
Yep.
you know, given the exponential nature of how these things progress, I think some pretty neat stuff are on the horizon. All right, this next comment is also from YouTube. This is from Fabio Milan. They write, hi, can I give a suggestion for a good interview? There are 2 scientists working on battery technology that were in the media some months ago, talking about a solid-state battery that could be the next breakthrough in battery technology. I think their names are Dr. Braga and Dr. Goodenough. Can you guys interview them?
Well, I don't know, SciComm, if you head to and read the next thing on the rundown, I mean, you might have an answer to that question, because our next...
As it
Yes.
turns out, next month, again, you spoke and we listen. Next month, our next show, which is going to be on May 5th, we're actually going to be talking to Professor Helena Braga about glass solid-state batteries. So be sure to tune into that, and that should be a fascinating conversation.
I am so excited for
gonna be
that
good.
episode. It's gonna be so cool. It's like these batteries that like they're solid. Like the electrolyte is solid and made of glass, and that's really, really cool because they're better than lithium-ion batteries, and it just makes me really, really excited.
So if it's not going to be the Energizer Bunny, then what's it going to be with these?
It's gonna be the glass solid-state electrolyte bunny.
Yay!
That's awesome. Like,
and just in time for Easter's.
Right? Totally.
So many cool bunnies. Awesome.
On that
so
note,
good.
you might notice that it's not quite April yet, but this is technically April's show. Because of scheduling conflicts, we moved that show a week forward. So this is the second show for March, this is actually April's show. So there is not an episode of Tomorrow Science in April. Our next episode will be on May 5th.
If you can wait that long, that is. I mean, I know
also-
I can hardly wait, so.
Yeah, it's
All
also
right.
the launch of the InSight lander. By the way, I'm going to be going to NASA for that. So
that'll be
just
fun.
got accepted for their NASA social. So excited.
Awesome.
So that's going to be cool. But that's, also the launch, 4 a.m. We'll see if they stick to it. I hope so.
So you can go to the launch and then you can drive back quickly and still make it for the show?
I literally was thinking
Oh my
that. I was
goodness.
like, you're going to be there too? Yes. Oh, I'm so
Already.
excited. Oh, yeah. You and me, Jared, we got this. It's going to be so good.
Nice. I guess we'll see each other there, maybe.
I'm not going because I'm a dirty foreigner.
Oh.
Something ITAR, something US citizen. I don't know how that works. Anyway,
That is blasphemy. Well, now I don't want to go just to protest.
it's fine. I'll be here
No.
prepping the show. It's all good.
Whatever. All right, so that concludes the comments that you guys left us last month. Again, please leave us comments on YouTube and Twitch, and then we can address them in the next month's show. So before we head out, we'd like to give a shout out to our ground support citizens who contribute $1 an episode on Patreon or $1 a month on makersupport.com. Again, they get their name in the show during the third segment, access to our exclusive citizen-only hangouts, and early access to After Dark as soon as it's available on demand. Again, if you want to contribute, go ahead and head over to patreon.com/TMRO or makersupport.com/TMRO. That concludes Science 1.04. We will see you May 5th. Thank you so much for tuning in, and stay curious.
Bye.
Bye, guys.